Hi kids, I wanted to talk with you about how we can graph a quadratic equation in standard form. This is a quadratic equation. It looks different than the ones we've been working with. It's not in vertex form, but standard form. We know it's a quadratic because it is a second degree polynomial, meaning that it has an x squared term in it. But it does look different than the vertex form. So let's get started. Standard form looks like this generally. It's y equals ax squared plus bx plus c. The thing we want to keep in mind when we're looking at these is that the values of a, b, and c are actually coefficients and a constant. So when we're looking at this particular equation here in problem 1, we can identify the value of a as -2. And we can identify the value of b as 12. And the value of c is equal to -20. So those are important because they help us with a couple of different things. The next thing we want to do is see if we can figure out how to find the axis of symmetry. That's the first thing we want to find, is the axis of symmetry. So the axis of symmetry is going to be found as the vertical line where x equals -b over 2a. So in this case, we would plug in the b and a values from our particular equation, and we would do all the math required in order to figure out what the value of x is so we can find our vertical line that is the axis of symmetry. So that would mean that we have -12. Pardon me, I just wrote a -12. It's actually just -12 over 2 times -2. So that would mean -12 over -4, which simplifies to the number 3. I apologize, I just went off screen. There we go. So the axis of symmetry is the vertical line where x equals 3. So the nice thing about that is that we know that the axis of symmetry is the vertical line that passes through the vertex point of the graph and splits the quadratic parabola in half. So let's see, let's find where that is. The vertical line where x equals 3 is here. There it is, x equals 3. Now, if x equals 3 for our axis of symmetry, and we know that the vertex point is on that line, that means that the vertex point is going to have an x value that is equal to 3. We just need to find the y value for that. It has to have an x value of 3 because it's on this line. So how do we find the y? Well, we just plug in our value of 3 into our quadratic for the x's and solve for the y. So y is going to equal -2 times 3 squared plus 12 times 3 minus 20. Now we just use our order of operations to find the value of y. This is going to be 9 times -2, so we've got -18. Then 12 times 3 is going to be 36 minus 20. We add left to right, so -18 plus 36 is going to be 18, and 18 minus 20 is going to be -2. So now we know that the actual vertex point is really the point 3, -2. We can graph that on our line or our axis of symmetry. So let's see, 3, -2 is going to be right here. Always want to make sure we label the vertex, the coordinates of the vertex. Next, so let's see, we took care of two things. We took care of the axis of symmetry, the vertex point. Next, we want to find the y-intercept point. Now, you may remember that the y-intercept is always going to be where x equals 0. So if we know that that's where x equals 0, that the y-intercept point is where x equals 0, then really all we have to do is plug in 0 into our equation. So for the y-intercept, x is always going to equal 0, so all we have to do is replace these x's or substitute 0 in for those x's. So let's see, we've got y equals -2 times 0 squared plus 12 times 0 minus 20. And of course, really what we're saying is that the y-intercept point is where x is 0 and y is -20. All right, so that point is 0, -20. Now on my graph, way over here, I kind of run out of y-axis, although we do know that this continues forever in the negative direction. So I'm just going to extend it and say, well, my -20 should be here. So there's my y-intercept point. I'm actually going to extend my axis of symmetry as well so I can see how far away from the axis of symmetry I am. So on my graph, I have graphed and labeled my vertex, I have graphed and labeled my y-intercept, and I have graphed and labeled my axis of symmetry. The only thing left to do really is to find the reflective point of this y-intercept. The y-intercept is 3 units to the left of the axis of symmetry. So now I need to go 3 units to the right of the axis of symmetry to sketch its reflective point. If I go 3 units to the right, that's going to take me to 6, -20. So I sketch and label it, and now I can sketch my parabola. And there we go.